begin. Today's December 25th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 2, 6, 12, 16, 19, and 21. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at our middle digit, the square digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D will take a look at the 3-digit solution, and the Turing Machine will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E will take a look at our first 2 digits, triangle and square, add them together, and the Turing Machine will compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again takes a look at our 3-digit solution, except this time the Turing Machine will let us know a little bit about the structure, so to speak, of our solution. Should the solution have a pair of digits, as in the example 131, or should there be no pairs? Now, there are 2 cases of no pairs, and those 2 cases are, the first one being where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. Now remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing Machine approves of my choice in square. I did pick an odd one, so the Turing Machine confirms that yes, that middle digit, that square digit, must be odd. So let's go ahead and type that up in our notes in section B, and we'll say that square is an odd digit. And since it is odd, let's go ahead and cross out the 2 evens. Okay, I think the next thing I'd like to test is criteria card D. Okay, so again, the Turing Machine does approve of my proposal. Remember, criteria card D is letting us know the ratio of even to odds. In my proposal, I do have 2 odds to a single even, and the Turing Machine approves of that. So yes, it is true that there should be less even than odds. So let's go ahead and type that up in our notes in section D. And again, we'll just type it up as there are less even than odds. Well, we do have a majority of odds. So we do have at a minimum 2 odds. So I'm a bit torn between testing criteria card E and F. Criteria card E has 3 possibilities. So let me go ahead and test criteria card E. Okay, wow, very fortunate. The Turing Machine approves of my proposal. Notice that for triangle and square, I do have 3 and 1, and they add up to 4, which is less than 6. And of course, the Turing Machine approves of that. So let's go ahead and type that up in our notes in section E, and that is that triangle plus square should be less than 6. And so what can we say about that? Well, we know that if we want to restrict the sum to be less than 6, I don't believe triangle nor square can actually be 5s. Because when you have a 5, and if you add even the smallest of 1 to it, that's already 6. And of course, if you pick something bigger than 1, that'll be even greater than 6. So we can actually cross out both 5s. Now, what else? Well, we can keep the 4 in triangle because you could add it to the 1 in square. But obviously, it couldn't be triangle 4 and square 3. But that doesn't allow us to cross out anything. Well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our triangle value to 3. Obviously at this point it's kind of broken into, well, it's either a 3 or greater than 3, which would mean it's a 4, or less than 3, which would be 1 and 2. We also did not test criteria card C, comparing our first and last digits. And we don't know if there might be a pair. Remember, we do have at least 2 odds. Could be those 2 odds are paired up, or they could be all distinct. Not sure. Okay, well, the obvious thing from round 1 is we got 3 checks. Could it be possible that we have the solution of 314? Well, that's a possibility. It's always a possibility. But let's keep going and think about what could happen. Yeah, I mean, even criteria card, I guess, C, it's pretty wide open. Anything is possible. They could be paired up. We have triangle values that are bigger than circle. So we need something definitive. And I'm thinking about triangle. I think it might be either 3 or 4. What could that be? Because maybe you want to think in extremes, that maybe if triangle were greater than 3, meaning the 4, you want to force the issue with square so that the sum, you would have to pick a 1 for square. So that'd be 4 plus 1. And then perhaps circle being greater, maybe. So that way, since triangle is 4, the only valid value would be a 5, where circle is greater than triangle. I mean, there's just so many other possibilities, but let's go ahead and try that out. I'm going to pick 415 as my second round proposal. And just to double check, is that middle digit odd? It is. Are there more odds? Yes. And the sum is still less than 6. Let's go ahead and try that out. Well, the whole purpose of this proposal was basically having triangle be greater than 4. So let's see. Could we ever deduce that? What if criteria card C is also true and that circle is greater? What would that mean? If you want circle to be greater, I think that would mean you would only be able to cross out the 1. I don't think, that doesn't seem too beneficial. Let's go ahead and let's test criteria card A. Okay, so no. Again, I did pick a 4 for triangle. 4 is greater than 3, but the Turing Machine does not approve of that. Not good. Okay. So what we'll say is that triangle is either less than 3 or equal to 3. So we'll say triangle is less than or equal to 3. And so our 4 did not work out. So let's cross it out. And what do we have now? Anything? There are lots of pairings among triangle and square. Obviously, you can't have 2 3s because that is a sum of 6. But either 3 could always be added to, 1. So, so I think that's about it. Let's go ahead. Let's now test criteria card C. And also incorrect. Okay, wow. Now I'm thinking, well, maybe it is 314. But now let's continue. So I did pick a triangle value that is less than circle. The Turing Machine does not approve of that. So that means that either triangle is equal to circle or is greater than circle. So let's go ahead and type that up. And we'll say that, and that's in C, that triangle should be either equal to or be greater than circle. So let's see, can we cross out anything? So if triangle, well, because of the equal, you could always equal up the number. So triangle can equal circle. So 1 can equal 1. So no, we cannot. I don't think we can cross out anything. Well, that's very interesting. Okay. And triangle can be bigger. Oh, wait, what about? Okay, so we know, let's see. Can we cross out 4 and 5 in circle? Well, 5 cannot be equal to triangle because there is no other 5. And if circle were 5, there's nothing bigger for triangle to be. Yeah, so we can actually cross out the 5. And I think the same thing with 4, because even with 4, there's no 4 to be equal to in triangle. And if circle is 4, there's nothing triangle could be to be greater than it. So yeah, so we can actually cross out 4 and 5. Well, that turned out, better than expected. So we're down to just 1s, 2s, and 3s. And remember, we can't have 2 3s in triangle and square. We know that much. I wonder how criteria card D, now that we know we have a majority of odds, how does that play out? Why did the puzzle makers choose that card? Does it mean that we do have a 2? Well, let's test criteria card F. I don't think we can deduce it. Okay, so interesting. I do have a proposal that has all unique digits, but the Turing Machine does not approve of that. So I basically have no pairs, but it doesn't approve of that. So there is a pair. So let's type that up, and we'll say that the solution has a pair of digits. And so what does that mean? So either we can't have 2 2s, that's for sure. So we either have 2 1s or 2 3s. Okay, so let's see, is it worth typing out all the possibilities? Well, we also haven't established what triangle is. So let's see. If triangle were 3, which is one of the possibilities, that would mean that circle got paired up with a 3, and it'd be 3, 1, 3. That's one possibility. So let's go ahead and type that up. I'm hoping that maybe there'll be some ambiguous solutions that we'll be able to eliminate. But we'll say that 3, 1, 3 is one of our possibilities. Now, that does have a 3 in triangle, but you could also have 3, 1, 1. That's another possibility with triangle 3. So yeah, 3, 1, 3 or 3, 1, 1. And again, both of those are where you have triangle is 3. So let's take a look at that. Are these ambiguous? Well, again, we're presuming that triangle is 3, which they are, and they both start with 3. That middle digit is odd. It's true for both. The other thing we don't know is, should triangle be equal to circle, right? That would be this 3, 1, 3. Or is triangle greater than circle, which is 3, 1, 1. So there's our distinguishing trait. So they are not ambiguous, because this criteria card is still outstanding. But everything else does, match up. But criteria card C would distinguish them. Okay, well, let's continue. So those are not ambiguous, and C would distinguish them. What if you had, could you have 2? I guess you could have a 2, 1, 1 or 2, 3, 3. 2, 1, 1 or 2, 3, 3. And what would distinguish them is, well, they would both be less than 3 for triangle. What would distinguish them is criteria card C again. Is that first digit greater than circle, or is our first digit less than circle? So again, that's what distinguishes them. Okay, and everything else seems to... So we see that, yeah, criteria card C still plays a big role. Now, what about if triangle were 1? So it could be, I guess, 1, 3, 3. It could be 1, 3, 1. Or it could be, now the following, let's see, 1 is not paired up. So 1, 3, 3 and 1, 3, 1. So again, yeah, between these two, what distinguishes them again is triangle. Is it less than or greater than, or are they equal? Well, hold on. Oh, I don't think it could be 1, 3, 3, because in that case, triangle is smaller. Oh, maybe, you know what? Maybe I overlooked something. Yeah, triangle cannot be smaller than circle. So the first cannot be smaller than the last. Equal, greater, greater. So 2, 3, 3 also fails. Okay, we can cross out 2, 3, 3 and 1, 3, 3, because in those cases, our first digit is smaller than our our last, I should say. So we can actually cross those out. 1, 3, 1 is equal. Okay. And let's see. So 1, 3, 1. 1, 3, 3 I already had and crossed out. And then how about 1, 1, 2, and 1, 1, 3? So I think those would be ambiguous, because in both cases, triangle is smaller. So actually, yeah, you wouldn't even consider them, because they wouldn't be, triangle would not be equal, or greater than circle. So yeah, so it can't be 112 or 113. So those aren't even worth considering. So 112 and 113 fell for that fact. Okay, so what does that mean? We got 1, 2, 3, 4 possibilities, and let's see, equal, greater, greater, equal. So it looks like we have two, or half of our choices are, either equal or greater. So that's our 50-50. And then we have two of them have a 3, and the other two are smaller than 3, another 50-50. So it looks like we're going to have to definitely go into a third round. And so the question is, what is the most likely scenario? Can we see anything in the list of potential solutions to really sort of, see if we can deduce? Let's see, is there anything that would distinguish these? Well, obviously having a 3 is decisive in triangle. Whereas over here, you'd have to, either pick a 2 or 1. They both work, but, how would you basically choose between them? So if that's the case, now do we make triangle and circle equal? That may be another sort of decisive play. So I'm going to go with 313 and see where that takes us. Let's see if we can basically deduce some of these characteristics. Okay, so the outstanding criteria cards are A and C. So which one is more relevant? Again, they're both 50-50, but I'm not sure. So let's go ahead and test criteria card C. Okay, so yes, the first and last should be equal. So let's go ahead in our notes, cross out the greater than. We know that they are equal. And so let's cross out 311 and 211. And so it comes down to either being 313 or 131. So they are equal. Yeah, 33, 313, and 131. Now, my gut feeling is that it is 313, but, I don't think, like I said, I like the 3 in triangle because it's decisive. It is equal to 3. But, alternatively, could you, well, let's see. So we know they're equal. So the question is, well, we know it can't be, 232. So does that mean that, let's see. Yeah, because, you can't have a pair of 2s now. So I think you can cross them out. Now, I'm not sure if that's really a big deal or not. But, you can't have a pair of 2s. So, and the only way that you could pair them up is if you pick them. So that would break criteria card D. So you couldn't have a pair of 2s. So if you pick the first 2 and it'd have to be paired up. Well, hold on. I guess technically you could have 211. No. They wouldn't be equal. If you pick this 2, you're forced to pick that second 2 because they are paired up, first and last. So if you pick that, it would break that rule. So you can't pick it. And so if you can't pick it, you cross it out. Now, you can't, and because you're left with odds on top, that means you can only pick odds on the bottom. So yeah, so you could cross out that too. Okay, minor little detail, but so yeah, is it 313 or 131? Is there anything in the criteria cards that would help us choose? Yeah, I don't see anything other than, yeah, just having to test criteria card A. So let's do that. Okay, wow, look at that. So it does not like that I have a 3 in triangle. So in my proposal, I do have triangle equal to 3, but the Turing Machine does not agree with that. So great call. Having to test criteria card A, so we know that no, triangle is not equal to 3. It must be less than 3. So let's go ahead and cross out the 3 in triangle. And because we have a 1 in triangle left, and it's got to be paired up with circle, that means circle can't be a 3. And because we do have a pair, we can't have an all 1 solution. So it must be 131. Okay. Well, we definitely got our money's worth on this puzzle. So let's go ahead and type up in our notes 131. And let's see, I think we've done enough analysis. We've tested enough where I feel very confident. Let's go verify 131 as our solution. So 131. Fantastic. Well, how do we do versus the Turing Machine? Well, this will be cutting it close because it is a 6 criteria card puzzle, but we did 8 tests. But if you notice, criteria cards A, C, and E all have 3 possible choices or options. So yeah, maybe a lengthier solution will still get us the tie for the win. So in the first round, we did get all of them correct. We did B, D, E. In the second round, we did the remaining 3, and they were all incorrect. And then we retested A, C, with C being correct. So let's go ahead and type that up. That was B, D, E in the first round. So B, D, E, all correct. Second round proposal wasn't even close, but we learned from our mistakes. And in the second round, I believe A again was incorrect, but C was correct. So let's see, how do we do? Okay, yes, we tied with the Turing Machine, but that is our win. So like I said, we got our money's worth on today's puzzle. And, you know, we just listed out all the possible solutions. We talked them through, eliminated those that did not fit, and then tested what was necessary. Well, what about you? How did you solve it? Did you learn anything interesting in your choices in criteria cards or proposals? Add those to the comments. And before we conclude today's video, just want to wish everybody a Merry Christmas and a wonderful holiday season. And this is a time of sharing. So share your love of Turing Machine with your family and friends and enjoy it. Well, until next time, have a great one.